Okay, so here's chapter 9. We're going to get started, I guess. Some of you are like, hey, it's not 8 o'clock yet. I'm like, well, remember all those times where I started after 8 o'clock? So here we are with the big payback. So I think we're good. Let me just double check a few things on my end. Okay, I think we're in good shape. Yeah, we're in good shape. Okay, so good morning, everyone. There will be 2 segments throughout the lecture where you're going to actually, there'll be some interaction between you and myself, so just be aware of that. And if you have coffee, just be sure to not let it get spilled during these interactive moments. And you will use your calculator at some point, so go ahead and get that out as well. All right. So anyway, moving on to chapter 9, if you will. So chapter 8, what we did was we collected data through sampling, right? So we posed some questions and analyzed responses, okay? And we had 2 different types of sampling. We had so-called scientific sampling and so-called non-scientific sampling. Also, at the end of class, I'll show you some resources that are available to you for your exam on Monday. So then now we're going to deviate from question posing, if you will. There are more ways to collect data than just asking people questions. And we're going to now start talking about other data collection techniques, if you will. Alright, so anyway, we have a few terms, if you will. We have the so-called observational study, and you just kind of sit back and see what happens. So you observe individuals and collect some data. And I'll try to have an academic example as well. Alright, so an academic example would be if someone was to try to observe my teaching with some feedback from me. They come in the classroom, sit in the back, take notes, that kind of thing. That would be like an observational study. Or if they wanted to observe how we conduct our class and take some notes, they don't necessarily influence our class. They're not injecting some kind of new idea. They're just kind of recording what's going on. So they're doing an observational study. When I was a teaching assistant back in the old days, I had to do some observation hours of different high school teachers, and then go to their classroom, and then I did student teaching. And you probably are familiar with that kind of model. So there's no active treatment there. In the experiment, on the other hand, you're going to actually impose some kind of treatment, some kind of idea, okay? Not necessarily always medicinal or health, allied health related, where you're going to actually inject someone with something. A treatment could be, some kind of new model. So again, the academic example would be group A gets a review sheet for midterm 1. Group B, no review sheet. So in this case, again, no one's actually going to each student and giving them a shot of penicillin or anything, but one group is going to get a review sheet, one group is not, and then we'll collect the data after the midterm and compare the results. And we'll see the effectiveness of the review sheet among other variables. One more thing to note is that this guy here is passive. This guy here, active. You are passively observing some kind of response. Here you actively are influencing a response. Okay, so let's see here. Yeah, with the observational study, you're just kind of sitting back. You can't necessarily say that there's a cause-effect relationship going on. And then with the experiments, as much as possible, we're going to try to attribute any changes to the actual experiment that we're conducting. So again, with the academic response, or the academic example, academic. Okay, so then in the academic example, basically what we're going to say here is that if there's any performance difference in the two groups, it's because one group got the review sheet and one group didn't get the review sheet. Not because one group got an earlier start or one group was on Wednesday, Friday versus Tuesday, Thursday, but more so our experiment here was the reason why things behave a certain way. Remember this concept from chapter 4 and 5? You had an explanatory variable x and an explanatory variable y, and then we'll say that that was the explanatory. This is the response. And then what do we call this variable z? Lurking variable, right? Kind of lurking in the background, sneaking up on the response. And the idea was that maybe it's not just x influencing y, but this other lurking variable lurking in the background, so to speak. That's also kind of influencing the results. So the same concept is back in chapter 9. Okay, so in chapter 9, now the same idea is back. Explanatory variables or lurking variables can kind of confound the response variable's behavior. So a good example with the academic example could be that maybe one group got the review sheet, one group didn't, but maybe I kind of show preferential treatment towards one group versus another, or I gave one group videos to look at and then also influence their test scores more so than the review sheet. So you want to try to control for those other variables as much as possible. Either even them out or take them out. And then the word confounded, yeah, that's no problem. You know, so we'll do our scheduled interactions around the quarter of the hour, and then maybe you'll be out by the quarter till. No, I don't count on it. Maybe 8:55. All right. So observational studies are not as effective at causing cause and effect because you're just sitting back. Too many things can go on. All right. So you gotta be careful about making conclusions. And then, of course, here's an important point. In a good, perfect world, the researcher tries to minimize any kind of confounding that's going on. All right, so coming up, you have, there's a lot of writing in this particular chapter, right? A lot of terminology, if you will. So let's see here. You have this, you have subjects, you have, I think, treatments and factors. Before I inundate you with blanks to fill in, let's try to think about this first. So subjects, we've seen this concept of subjects before, all right? Subjects themselves are like individuals. And if you're filling in blanks, technically, individuals comes first. The factors themselves are explanatory variables. And the treatments, of course, we'll tune in later, okay? But before you start filling in blanks, just kind of let that sink in. Individuals in a study are my subjects. The explanatory variables from chapter 4 and 5 are now called factors. And then because you have multiple factors, the levels of the factors are called treatments. And now we fill in blanks at will, all right? So, yeah, when you're studying folks, they're called subjects. It could be animals, it could be objects, whatever. When you're looking at explanatory variables, they're called factors now. And then treatment is applied to all subjects, or the treatment is applied to the subjects, not all the subjects. Most of the time, and for your midterm, you'll get one factor to mess around with. But if you have multiple factors, I'll show you how to handle it. Here is a multiple factor example. Weight loss is the response variable Y that's being studied. And then I could have two factors that I think are critical to impacting weight loss. Dun, 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 dun. Diet and its close cousin, exercise, right? We'll call this guy X1 and this guy X2. have some room in the margin, you can fill these things in. And then I would have diet option, let's say here, no carbs, and we'll call it standard. Okay, that's kind of run out of room, but that's no carbs and standard down there. And then we'll call this guy, you ever heard this guy Shaun T? He does like this hip hop abs or these different movements, right? So you have this Shaun T, hey, right? He does all that stuff. Okay. And then we'll say status quo. Insanity. He does an insanity thing. I'm more with it. Okay. So anyway, these are my two variables. Here's my two factors. Here's my response. And so then the treatments, ladies and gentlemen, how many treatments do I have? What do you think? 4. Explain, what are the 4 treatments?
The no carbs and the standard diet and the Shaun T and the status quo.
Right, so then what I could do is then my treatments, and you're like, okay, you ran out of room. I can have no carb and Shaun T. That's one group. I could have no carb, how do you spell carb, and status quo, which is basically, you know, you're not doing anything different per se. Or I can have my, that's different. Or I can have my standard diet and Shaun T. Or I can have my standard and status quo. Okay, so you know, it kind of ran out of room here, but hopefully it gets the point that the treatments are the different combination of factors, and then you see how each of these categories, what the weight loss is like for each of these categories. No carbs, high intense workout, hopefully lose more weight than someone with the standard eating habits and the status quo as far as exercise is concerned. And you just kind of divide your patients up into 4 different groups and observe them and then measure the weight loss. So there is a slight digression there. Here's an example here. Read through it. Crohn's disease is something I'm familiar with just from relatives and that sort of thing. So read through it, and on the exam, you won't be given this much background, because that just takes up too much time. We only have 55 minutes. But let's kind of cut to the chase. Let's see here. Injections of this thing. So you get some kind of injection. Oh, here we go. Bam. All groups received an injection and a pill. And some pills were the placebos. You know what placebo is? Like nothing really is. There's no effect going on there. Sugar pill. Yeah. I put down that there's 510 students or 510 participants. How did I get that? Out the blue? What do you think? 3 groups of 170. Yep. The very last sentence. So on the previous slide, you saw an example where I had 4 groups, right? This group, diet, exercise, so on and so forth. Now I got 3 groups, okay? And then that's how you get, you know, 170 in each group, 510, boom. There are other questions. What are the factors? The factors are going to be whether or not someone got the injection and whether they got the pill, what type of pill they got. So, you know, I'd be okay with someone saying type of injection and type of pill. That's totally fine. The treatments, okay, I guess they didn't give anyone, it's kind of like the previous example. They didn't give anybody placebo injection and placebo pill, right? So they're basically saying we're going to do something with somebody. But yeah, those are just different combinations, different arrangements, if you will. Injection, pill, injection, placebo, placebo injection, pill. Technically, there's one placebo injection, placebo pill, but I guess they said, no, let's not do that. That's fine. Because you could argue that you already have current data on what it's like to have, that's your control group, right? No injection and no pill. What else do we have? Oh, the response. This is Crohn's disease, and you read through it, 3 groups. Here we go. Outcome. End of this project. There we go. Defined as how prevalent the disease is after half a year. So the last one is whether or not the disease is in remission after half a year. Okay, so let's see here. Yeah, we'll talk about this a little bit here. So this kind of topic here is important to me for Monday's purposes. Okay, it's kind of like the essence of chapter 9. So, you know, you have your computer, you want to circle, highlight, whatever you want to do. All right? So this is the general structure of chapter 9 for randomized comparative experiments, and you want to compare 2 more treatments, that's fine. With random assignment, you have your calculators out. And then you got the big 4. Randomly assign people to groups, give them some kind of treatment, and compare the results. That's the essence of experimental design. The rest of it just kind of builds upon that. And I'm going to call random assignment RA, not residence hall advisor, whatever it's called. Assistant. All right, so here's what you can kind of use for that space where it says draw a diagram for the Crohn's experiment, if you will. You have your 510 people. There's my random assignment. These are my different groups. These are my different treatments. And then lastly, we're going to compare the results. So use some kind of computer or technology to put them into this group here, and then after half a year, see how many people still have issues with the Crohn. See how prevalent Crohn's disease is here. So we'll call this a remissions rate for injection and AZAP. So you get one remission rate, right? And then now you get a remission rate for injection and placebo. And then you get a remission rate for placebo and the AZAP pill. So then theoretically, these different R values are different. And then what we would say, because we randomly put people in different groups, we can't say, well, you put all the stronger patients in this group, Dr. Baker, of course they're going to have quicker or lower levels of higher remission rates, I guess you could say. Well, if you randomly do it, that kind of lets you off the hook. No one's going to blame you as much anymore because you randomly did it. So randomness kind of helps things behave the way they're supposed to behave. So go ahead and fill that in. Now, today is a day of heartache for some and happiness for others. And for many, it's just a day on the calendar. But in this class, you have the benefit of being at least recognized for all your coming to class at 8 in the morning, during the snow, during the cold. You should be giving me candy because you want good grades, right? But that's okay. That's okay. So I won't take it personal. So what I'm going to do is take a little short commercial, no problem. And then if you would just tell me how many of you want candy and how many of you want chocolate, I'll come by and give it to you in each row. And if you have a computer, I will not knock it down. So how many for this row, candy or chocolate? Are you trying to be picky? You ain't looking for chocolate? Okay. It's just one of these kind of things. Chocolate? Chocolate. It's going to be tough with the chocolate get to the back row. I don't know. Sorry, no one said chocolate. Candy, sure. Don't get picky with the colors. All right? Yeah. Two chocolate, 3 candies. I feel like I'm looking at a restaurant. All right. Yeah, right. All right, what about you guys? Chocolate. 1 and 1, 2, 2 and 2, 3 and 2. Now, please be nice to the class behind us, and don't leave like wrappers all over the place. Okay. All right, you agree? Candy. All right. You have 2 candies. 1 chocolate. Yes. So that's 2 and 1, 2 and 2, 3 and 2, 4 and 2. secretaries at work, though, look quite well. All right, that's the first interaction for the day. I did all the interacting, right? But oh well. There we go. So now we're going on to the next part of the day. Principles of experimental design. You want to control for lurking variables and that sort of thing. And randomization tends to go ahead and help you with that control component. Now the next thing you're supposed to do, according to my notes, is take out your calculator, which you have done, right? And you're supposed to simulate assigning 10 people to a treatment. So you may not remember the exact steps of how to get there. What was the function for randomly assigning people to some treatment? Well, it's probably random. And it's under math, probability, random integer, exactly. And you guys know what integers are, so that's good. So random integer function. So go ahead and determine or identify 10 people to sample or to administer some treatment to. And I would do something like that. Random integer 1 to 500, 10 people. Okay, now you're on the hook, right? So, can someone who received candy raise your hand and give me your 10 numbers? They can't on your calculator. Yes, ma'am? Your name, is it Rihanna?
There's no Rihanna in here.
Are you sure?
It's Brianna.
Oh. Maybe I'm just thinking about Ella, A. All right. Just kind of skip. Anyway, all right. So go ahead. 203. 367. 22. 170 is my phone. 498. 101.
400. 476. 111 and 185.
187. 185. All right. Raise your hand if you got these exact same 10 numbers. Why not? Because it's a random process, right? So theoretically, now she does the sample again, she'll probably get 10 different numbers. And there is a chance, though, that you might have gotten one repeat, maybe one repeat. And just do random integer for one number and then replace that one. So the way it works is you have your numbers 1 down to 500, and then these are the people that you would administer some treatment to. And then you just go on about it. So you don't necessarily need to write down her numbers, but it's the idea that you can write down your numbers and everyone's happy. Okay, so anyway, more principles of experimental design. So that was our second kind of interactivity for the day. You doing some kind of calculation, me passing out candy, everybody's happy. There's that. Now, statistical significance occurs when the effect is so large that it cannot be attributed to chance alone. And think of it this way, right? Let's go back to that weight loss example. Suppose people typically lose about 5 pounds, maybe give or take a couple pounds, maybe Maybe some folks lose 2, some folks lose 8 or whatever. I don't know. Maybe that's a good range. I don't know, something like that. Okay? But statistical significance occurs when the effect is, it's not just like you're at 8.1 pounds that you lost or 9.2 pounds or whatever. Maybe you are clear out here at losing 13 pounds. That's where you use your knowledge about standard deviation, means, and so forth to figure out, remember that's 13 pounds, not 131. In case you look at this later on, like what's that to say? 13 pounds, and I put a little star. Statistical significance has a star with it. This guy has a star. And you say, oh yes, I lost 13 pounds because I had a no-carb diet and I worked out religiously with insanity. Girl, you should do likewise. Okay? So that was one of our treatments. And that's what experimental design hopes to do, is say, okay, we have statistically significant results as a result of one of our treatments. And then you publish a journal article, and Sean Teague is very proud of you. Let's see here. There are a couple of cautions we should think about here. Should everyone take the same treatment? Probably not. Should it be half and half? Well, how do you determine who gets the half, who doesn't get the half? This is relevant. What if the people know that they're getting a certain treatment? What if you as the researcher know who received the treatment? And spoiler alert, I'm a big Star Wars fan, so there'll be a Star Wars reference coming soon. You're like, what, Star Wars? Please don't say that. All right, episode 1, remember that? So, how might cautions 3 and 4 impact the results? Remember 3 was, I'm going to put this, so I don't text a lot, but it does come in handy for notation purposes sometimes, shorten things up. So what if you knew that you were in a study designed to help you not get the flu or whatever it is? What if you knew that? Well, how could you behave differently? Yes. Okay. How would you expect to behave? Okay. So if you knew that you're in a study where your health is supposed to improve, then you can start engaging in better health habits, right? So maybe, and that's what she's saying. Like, I just answered the question. That's fine, okay? But maybe you can start engaging in healthier habits. So it's not just that you're taking this pill or this shot once a week to help you get over this flu shot once a week. You're also eating better, you're also working out, you're also getting up and getting plenty of sleep. So all those other confounding variables are going to influence the results because you know what's going on. You're drinking orange juice, all that kind of stuff. Okay? what if the researcher knows who gets which drug and says too much to that patient? Right? The researcher could say, "You're feeling a lot better today, aren't you?" And you're like, "Yes, I do feel better." Right? Kind of like a Jedi mind trick. Okay? And then maybe if you were a patient that was not receiving the treatment, and you were the researcher, "Oh, you don't look so good today, do you?" "No, oh, that's too bad." Right? So the researcher can kind of play these so-called, in your notes, you know what I'm talking about, the Jedi mind trick, and basically say things that can lead the patient to believing one way or another that their behavior is either improving or it's not improving. Okay, so you gotta watch out for that Jedi mind trick. So the key thing, my friends, is to have a third party that's impartial, that knows who gets the placebo, who gets the treatment, and then don't tell the researcher and don't tell the subject. That's one of the goals. And then when that happens, we call that a double-blind experiment. Okay? Because we have someone like you that is the third party who use technology to figure out the random assignments. That's you, the statistician, so to speak, or the researcher. You got this patient over here who knows that they're in some study, but they don't know if they got the drug or not. You have the researcher over here, or let's call it the physician, if you will. Let's go let that fly. So there's, you have to kind of be like this buffer between the physician and the patient, and to keep them both in the dark on who has what, so they can both do their job. The patient can just respond, and the physician can kind of collect data without being impartial, or without being partial, excuse me. Now, single blind experiments is when one group doesn't know that they are getting the treatment or whatever. So then you have these placebos, and someone said earlier the placebo is a sugar pill, and they're correct. So it's administered to subjects. And then there's a comment about the placebo effect, if you will. And just look at this dynamic, right? We're talking about this whole issue of the Jedi mind trick. If you don't have a double-blind experiment, watch out for this. If you're a patient that knows that they're getting some kind of treatment, and you're a physician that's kind of reinforcing it, that's what this is kind of like academic speak for. The patient is behaving differently, the physician is kind of reinforcing that, then there's this like halo effect that can almost be synergistic in getting everyone to feel better and the results to improve. So you got to watch out for these kind of outside influences, if you will. I found it kind of cute. Anyway, the self-fulfilling prophecy, that's basically what we're talking about. Okay? So the placebo effect is a type of self-fulfilling prophecy. And it occurs when both the subject and the physician know what's going on and they talk too much. All right, let's go back before I divulge that. So the next one, how can I say it? Dr. Baker, I don't like controversial topics, but I don't like a boring class, right? So I like topics that are relevant, like the whole thing with the football player and NFL and that sort of thing, as far as NFL and openly gay athletes and all that. So another issue is marijuana, right? Medicinal marijuana, recreational marijuana, right? Okay. So, but marijuana can be addictive. Believe it or not, chocolate can be addictive, right? Chocolate kind of gives you a stimulant, right? But you know, marijuana can be kind of addictive, and so there's rehab, okay? And you know, there's all kinds of rehab. So we have this study going on here in the next section. You have 40 people. I make a patch that's been effective for people to stop smoking. Maybe it can work for people to stop, right? Okay, so you give a patch to everybody. Half of them get a patch with some kind of medicine in them. Half of them get a patch with like a placebo. So that's kind of what's going on in this next slide. All right. There are short-term risks from marijuana, like not waking up for class. There could be negative long-term effects as well, addiction, brain damage, what have you. I create some kind of patch. Dude, give me that patch. Yeah, okay, let's get the patch. All right. You have a double-blind experiment. 40 wore the medicinal patch, 40 wore patches that contain drugs. And then you want to see who's still smoking after 3 months. Well, what does it mean to have a randomized, placebo-controlled, double-blind experiment? We need the word experiment in there also. All right, so randomize. I'll call this 1, I'll call this 2, I call this 3. Well, the first thing is I'm going to randomly use some kind of technology to put people in different groups. Placebo control. I'll call this part 2. I give folks the patch with medicine, patch with no medicine. Double blind, I call that 3. You as a third party use some kind of technology tool, your calculator, computer, jump, whatever, and decide who gets the patch, who doesn't. Like I said, randomization helps you out, right? Because what if someone really, really, really wanted to patch with medication and they're mad at you for not putting them in the group that gets the medication? You can say, oh my gosh, it was a random process, nothing personal against you, the computer's fault, and you're off the hook. So those are 3 key things: technology tool that randomly divides things, patch, no patch, or medicine, no patch, no medicine, and yeah, you don't tell who gets the real patch, who doesn't. All right, how would you interpret statistical difference in cessation rates? And again, the same kind of concept from before. Okay, so there's that. I think here is the typical range for cessation rates after 3 months. But what we're going to hypothesize is that the rate for cessation, which is the stop rate, for those who had the medical patch or medicinal patch, was so much higher than this range. That would be an example of a statistical difference. And then that's just me talking, right? Everybody wants to stop smoking, and so it's going to naturally, you're going to naturally have folks who fall out. But then the cessation rates were far greater for those with the medicinal patch. That it must have been due to the patch, not just the randomness of being assigned to that group, or other factors like they were very determined, that sort of thing. Because randomness helps kind of even things out. So if you have someone who's really determined, you probably don't have all the determined people in the same group. They're probably split up evenly. Okay. We almost done? Oh yeah. So again, we have other examples. I went through an example before with like weight loss and Shaun T. So I think we're good on that. All right. Okay, so we have some block designs. So lack of realism, if the study can't occur, that happens. I'm going to borrow you for 2 minutes over. I bought you off with chocolate and candy, so you can give me 2 minutes. All right, so a block is a way of dividing people into some similar group. So in the sampling world, you had this thing called stratified sampling, where you divided people up into different strata. So strata 1, strata 2, strata 3, because you felt like some variable influenced the results. Blocking is the chapter 9 analog of that. And then in a block design, you're going to randomly assign people to different treatments. So, if you think that in the marijuana example, maybe the length of time that you've been a marijuana user might influence how quickly you are going to give it up. So let's say here, users less than 5 years, users greater or equal to 5 years. So what you do is kind of divide the people up into 2 different blocks. And then you carry out your experiment. Now you go ahead and randomly give some people the patch with medicine, give other people the patch, no medicine, and do the same thing for the other block. The patch with medicine, and the patch with no medicine, and then compare the results. Because you already think that people who are on it for more than 5 years are going to mess things up with the data anyway, so kind of separate everybody out. Okay, so then we have this match pairs design. Okay, so the pairs and subject are closely matched, and we call this like a pre-post kind of a thing. It's a good example. You remember how you want me? I'm going to ask you for 2 minutes. A pre-post study. So match pair design, you kind of take all people of a certain group and kind of compare, give one person the treatment, one person placebo, and kind of compare what happens. A common thing is to take twins, have one twin get the treatment, the other twin doesn't get the treatment. Okay, you can read about that. There's nothing new to add there. Okay, so here with the Crohn's example, suppose that researchers believe that older patients might have adverse reactions to either AZAP or Inflix. Well, dun 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 dun. Age should be your blocking variable. Anybody under 40, put them in one group. Those 40 and over, put them in another group. Okay? So if you have a hunch that there's some demographic that might influence your results, then kind of partition your subjects by that demographic variable. Let's see here. So again, this is kind of a long solution. I'll post this for you guys to look at as well. So let's come back to that at the very end. But I am interested in this before we go. What are 3 concepts that have the most impact on your knowledge of either Chapter 8 or Chapter 9? Give me one of them. You can't leave without saying one of those 3. All right, if you had chocolate, give me an answer. Yes, sir.
Blocking.
Blocking. What about blocking?
That you can use it to split up your data and then compare across.
Excellent. All right, someone else with chocolate.
The concept of the double-blind experiment, how the patient and the individual subject and the experimenter don't know each other.
Okay, good.
Status.
Double blind experiment. Last one, someone had candy or close.
Statistical significance.
Okay, what about it?
The fact that it kind of shows that you can't just solve it on ideas.
Right, it's probably gonna be so big of a difference that it's gotta be because of that treatment. All right, thank you for your time. I'll send you guys an email about some things that are posted online for you to look at. We have exam reviews posted. I have an old exam posted with solutions. I have videos of this class posted. I have PowerPoints with notes posted. And then I have something else posted. I'll send you an email.
Chapter 9 included in this midterm?
What's that?
Is Chapter 9 included on this midterm?
Chapter 9, oh yeah. Chapter 9 is on that, sorry. Alright, chapter 9 is on. That was the extra one together.
Can I ask you a quick question?
Alright, give me a second so I can kind of start tearing down.